This conference will now be recorded.
Dear students, here we discuss about filtering of long duration sequences using OLAP save method in MATLAB. Suppose the input sequence x of n is of long duration, then in this method we are dividing the input sequence into blocks of size n is equal to l plus m minus 1, and these blocks are separately processed one at a time, and the results are combined to get the desired output sequence, which is identical to the sequence obtained by linear convolution. So in overlap save method, let the input sequence length is ls and the length of impulse response is m. In this method, the input sequence is divided into blocks of data size n is equal to l plus m minus 1. Each block consists of last m minus 1 data points of previous block, followed by l new data points to form a data sequence of length l is equal to n is equal to l plus m minus 1. For the first block of data, the first m minus 1 data points are set to 0. Now, if you observe the program here, first instruction is CLC, which clears the screen and clear all the variables which are used previously and closes all the windows. Now here x is the input signal, h is the impulse response, and n is the length of the each block. Here x is equal input, enter the first sequence x of n, and h is equal to input of enter the second sequence h of n, and n is input of enter length of the each block n. Now we have to plot the input sequence x of n. To plot x of n, the instructions are subplot 2 comma 2 comma 1, stem x, and title x of n. So these three instructions will plot the x of n. Similarly, to plot h of n, we are using the subplot 2 comma 2 comma 2, stem h, title h of n. So these instructions will plot the impulse response h of n. Now we are using a function called over else SAV, that is overlap save method. For this overlap save method, we are using a function. So this is the function for overlap save method. So here first we are checking the size of the each block. If n is less than n is less than length of impulse response, then it will give some error. So in this, we are dividing the sequences into blocks. Next, similarly, one more function is there, circular for the circular convolution, that is called CAR, that is circular convolution dot m. So this is the function which will give the circular convolution of given two sequences. Now, if you execute this program, if you run this program, then it asks the first sequence x of n. Now, here you have to enter the first sequence. The first sequence here I am entering is 1, 2, minus 1, 2, 3, minus 2, minus 3, minus 1, 1, 1, 2, minus 1. This is the input sequence. Now we have to enter the impulse response h of n. I have taken here impulse response as 1, 2, 1, 1. I enter the length of the each block. So length of the each block I have taken here n is equal to 5. See this, each block has length of n is equal to 5. Here this is the given input sequence, This input sequences is divided into blocks of size n. Here how many blocks there are? 8 number of blocks. It divides into 8 number of blocks, which each block has a size of 5. Now if you observe here the first m minus 1 points are 0 for the first block. Why? Because for the first block there is no previous block, and remaining L points are taken from the input sequence 1, 2. For the second block, the first m minus 1 points here, first m minus 1 points are taken from the first block, that is previous block, and remaining L points are taken from the input sequence, that is minus 1, 2. Like this, it will form 8 number of blocks. The input sequences is divided into 8 number of blocks. Now, these 8 number of blocks are separately circular convolved with the impulse response of length L plus m minus 1. So initially the impulse response has length m. Now by adding L minus 1 zeros, we are extending the length of impulse response to L plus m minus 1. Now each the subsequence is circular convolved with the impulse response of same length. Then we are getting the partial convolution output as this one, partial convolution outputs. So this is the first block, the first sequence here. This is the circular convolution of first block with the impulse response, and this the second one is this circular convolution of second block with the impulse response like this, and the last one is the circular convolution of eighth block with the impulse response. So in these partial convolution outputs, the first m minus 1 data points are not coincide with the linear convolution, which are not identical. Why? Because due to aliasing. So we are discarding the first m minus 1 points in each partial convolution outputs. And we are considering remaining L points here. That is 1 in the first block 1, 4, in the second block 4, 3, in the third block 8, 5, and the last block 1, 2. So these points are the last the last L points in each block are concatenated to get the final result. So this is the final result, convolution of input sequence with the impulse response. Now, if you observe this figure windows, in this figure window, this is a plot of input sequence x of n, input sequence x of n, and this is the impulse response h of n, and the third figure indicates the convolution of the input sequence with the impulse response h of n. So this is the result of the long duration sequence convolution or filtering of long duration sequence using overlap save method. Thank you.